Let's get started. Like I said, today probably is the last day without actually using SAS. But I upload a lot of SAS code for you to look at it. And so you can just click on any one of them. Okay? And if you open it up, open with SAS. Okay? And I'm going to go through the code next week, one by one. But right now, you can see just a bunch of code. And most of the stuff at the beginning we're doing is not different from the Excel file we had before. Remember, we did some distribution. So look at this code when it runs. Run very slowly, but it run. Oh, here we go. And okay, you have survival, failure, over time, and sooner or later turn them into a 1 to 0 transfer function. Does it look familiar? And then you have the marking there. What are those marking? Sensor, data point. So, everything at the beginning, just like every course I taught, usually you will do the stuff you know you can do in Excel. And then gradually said that, wow, this is too much for Excel, too labor intensive. Then we'll let SAS take over, okay? So there shouldn't be any black box. And right now, your number one job is make sure you can run SAS either here, or you can use 213 in Cameron. But if you don't want to go to, come on campus, then you better get that code ready, download it, okay? And I have all the code I'm going to go through. And the other things I did is I give you 2 PDF files for some chapter of the books that I copy. And the books, if you want it, you can have the newer version, okay? And here's a University of Pennsylvania's professor. His name is Paul Allison. And he did survival analysis. So here's the books that if you want, you can have the whole books from. And he also published a few books on event history, logistic regressions, multiple regressions, and I like his books. His writing is very fun and clean. And even when he talks about math, he tried to make it intuitive. So if you want, please at least read the book chapter. Oops. I shouldn't do either. Okay. And okay. And so next week, okay, make sure you will have SAS homework from next week, okay? Please don't ask for extra time because you don't have the SAS ready. Okay, and today I'm going to keep going with psychophysics. And before I go any further, okay, Have you guys noticed this? When we talk about psychophysics, or when we talk about survival function, really is a bunch of log and exponential, right? I already explained to you log do three things. Well, we know log and exponential are inversible, right? But log, we said, do three things. What are the three things? Victoria, do you remember? Well, the first one is linearize exponential function because they're inverse. The second one is that whenever you have a data, it's trumpet shape, means the variation is scale dependent. The more, when you increase the scale, the amount of variation increase. That's why the data look like a trumpet. Then when you take the log, the data will become equal variance, okay? And then the third one is really the reason that we did log is d log x equal to dx over x. So in other words is that d log, the rate of change of log function becomes the amount of change at any given x level, right? Just write it down here. Is there an equation we can use? No, I'll do it here. Right? Everybody knows this. The log x d log x dx equal to 1 over x. So d log x equal to dx over x. So in other words, the rate of change of any log function becomes the rate of change of the x level, the dx, over what x level you're in. Okay? And why I keep talking about this is that a lot of time you will see that, well, survival function, a bunch of log, or exponential. I'm talking about psychophysics, a bunch of log. Weber's law, it's log. And the Fitchner's law, is law involved in this. And last lecture I talked about multinomial or logistic function is also kind of like exponential over exponential. Anybody can intuitively understand why those things are involved here. Okay, I think one way you can think about it is this. Okay, when we did the logistic functions, okay, see here, one exponential over exponential. And when I talk about multinomial, is exponential over, could be, like say I have 4 choices, 0, 1, 2, 3. And you can have exponential for 1, exponential for 2, exponential for 3, exponential for 4. So exponential itself, think about it, okay? You have an x, add the exponential, you kind of expand it. So expanded means you expand the uncertainty. So it's kind of like why things were jumping up and down. Remember I talked about psychophysics. I said that there's a ratio scale. We're talking about energy at absolute zero, negative 273 degree the Kelvin, the Celsius. It means that at that level, there's no energy. If there's no energy, there's no ability to jumping up and down. So there's no variations. There's no uncertainty. So when you have zero uncertainty, the exponential of zero, is 1. And so when you have something exponential here, just look at this equation here. I have a beta times x1, xi, okay, the x at a certain level. But you know that because of the compositions, okay, you have some energy you could use for 0, could be used for 1, could be used for 2, could be used for 3. But if every time when x at a certain level, you will go 1, that means that obviously at that range, you like to choose 1. You like to choose vanilla flavor ice cream or chocolate ice cream. Whenever the x reaching very, very hot level, now you like to go for strawberry ice cream. So you can consider this exponential of something. A beta times x is, the beta times x is, at that level, my exponential, my energy tend to be high. So if every time at j, the energy tend to be high, then the probability of the stick diagram tend to be high. So this exponential over all the possibility exponential basically is kind of like, okay, at what level of x our energy tend to be high to causing our histogram poking up a lot more than other situations. So exponential really is just, energy comparison. When you tend to have a lot more energy here or more energy there. And then you can consider that, remember we did a simulation of Poisson distribution for arrival rate. And then when we did the arrival, we also have the exponential in there, right? Why is that? It's basically how long I have to wait. So if you have a lot of arrival, then your waiting time gets very, very tight, smaller and smaller and smaller. So exponential, in a way, we're talking about, just put it down, okay? It's a way to express energy at a certain level. And log is what? It's a way to compress that energy and say that, why you tend to have that much energy? Because your x, right? Once I take log of this expression, become what? Upstairs, a beta. So log tend to linearize it, linearize the energy. Exponential tend to express the energy. Yeah, and in physics, the entire thermodynamics is just Brownian motions, all that stuff they love to talk about. It's all about exponential and log. But for system engineering or for engineering management people, okay, I don't care your master's degree or undergrad. By this time, you should say this, man, we've been doing this too many times. Why we always have this exponential or logs in our textbook, right? In your first normal distribution, what is a normal distribution? 1 over square root of 2 pi sigma. And then what? Exponential negative half of the z² Why we keep talking about this energy? Because the exponential talking about the opportunity for you to have a high stick diagram or not stick diagram, okay? I don't want to go through the mathematical proof, but I want you to have intuitions. You're not memorizing a bunch of equations. You should feel it. Exponential is the energy. Log is to linearize that, to figure out the relationship between whatever you try to measure and your x, covariate. Okay? And yeah, here we're just saying that, okay, under what conditions these things, energy tend to be high. If the energy tend to be high, then your odds ratio or log odds ratio at that tend to pop up more, okay? And coming back to this when I talk about SAS, we're going to talk about proportional hazard model. And in proportional hazard model, a lot of time people are talking about two things at the same time. They're talking about, well, when you tend to have a lot of event, have a lot of people die, have a lot of customer disappear, and when they only talking about that rate of change, they also try to figure out that exponential over exponential. So you can think this is, on one hand, we're talking about psychophysically how we feel about it. And that should align really well with how the event history, how many people die and how many things happen at that ratio, okay? And that's called proportional hazard model. Oh, by the way, anybody remember I mentioned this briefly? In three different type of SAS code. What are the three SAS functions in this class? One they call proc live test. Proc live test is the non-parametric method, and then there will be a live regression is a parametric method, and then the third one is called PHREG, proportional hazard. That's a semi method. And the semi method, the concept behind that is exactly the same as your logistic regression or your multinomial energy comparison, okay? And of course, the modern days, they call this neural network. How many of you use neural network so far? Anybody? Machine learning is all based on neural network. And neural network is about what? You have some input variable, some x, and then weighted by some parameter w. It's like beta. So beta times x1, beta 2 times x2. And then when you sum them up, all the beta together, that's called your hidden node. And then when your hidden node converted through a bunch of negative exponential, you said, oh, I'm going to go for decision 1 or decision 2. I'm going to buy vanilla ice cream or chocolate ice cream. They just basically turn a logistic regression of multinomial into a network expressions. So if you feel comfortable doing your exercise here, remember we did an exercise on this one to find, and if you go for any neural network book at the beginning, you will see similar exercise, except that they talk about that as a transfer function to activate their neuron. And what is activate your neuron? So you start from 0 and x increase. Finally, you start saying that I'm going to fire that neuron because the neuron is at 1 level, okay? And they probably will talk about the all or none's law in the neuron firing. Means that you need to give every neuron enough energy to stimulate it so the neuron will activate. So what is that energy? Expressed in exponential of something, okay? So if you pay attention, okay, in psychophysics, we're having this exponential over exponential expressions. In our original data simulation for the survival function, we see a lot of exponential over exponential expressions. And if you go to the modern, any neural network books, just go through any books, you will, with enough equation in there, you're going to see a bunch of this exponential over exponential expressions. They're all doing the same thing. Okay? When I was in undergrad, nobody talked about neural network. Okay? And then in the 80s, neural network suddenly becomes the magic word for a lot of stuff we're doing. But on the other hand, there's another term, we're not talking about it much. It's called fuzzy neural network. Ever heard that term, fuzzy logic? fuzzy means that linguistically hot, cold, somewhere in between. What do you guys think about our room right now? Hot or cold? Okay, cold, hot. So what do I'm going to have? I have a bunch of people. I consider every one of you as a one neuron. And then I'll have a voting mechanism. Some vote yes, some vote no. If majority of people say yes, then I'll say, okay, it's hot. Or majority of people say cold, I'll say it's cold. And isn't that the same things we did with logit, probit, right? We just try to figure out when you switch from 0 to 1. Where is that middle point? And I hope I can give you enough lip service so you can connect the dot of what we did so far. Okay. Next things I would also, no, I think I emphasize too much on this now. I'll go for something different. Okay? And now I'm going to talk about Stevens' power law. And power law is basically developed by J.J. Stevens and his wife, okay, in the 60s, okay, and Fitchner used log, and Weber's, they were formulating this in the Industrial Revolution, in the 1850, 1830-ish, okay, and by the time of 1950, what's so special about 1950? Second World War ended. United States is the superpower dominating the science and technology and everything. And they, they got some of the ideas from the Germans about how to develop jet engine, develop rocketry. You guys know von Braun, the chief rocket scientist in NASA, for NASA, in the 60s, in the Apollo missions. You guys know where von Braun from? Nazi Germany. He was the engineer there before, and of course, you guys know what's the difference between, during the Second World War, everybody talking about, right, the Russians coming from the east tried to take Berlin first. And of course, Patton and Montgomery, the British and American coming from the east, from Italy, Normandy, and they trying to take the Berlin from the west. Well, anyhow, why we are in so much Allied forces interested in Berlin or taking over Germany? Because there are a lot of German scientists and a lot of innovations. Let's face it, okay? During the Second World War, the best tank is the German tank. The Germans couldn't maintain because they don't have enough fuel and they don't have enough industrial power to sustain the battle. Just like, the Japanese Zero airplanes, not bad, but they just don't have enough material to do it. And why I mention this is that when the Ally, coming no matter from the east or west, tried to take over Germany, part of the deal is that we would like to get enough about the intel of German military might and their creativity. And what's the difference between the Russians and the Soviet versus the Allies? The Russians, a lot of times, they got the hardware, or they got the blueprints of the design. But American, usually, we got a scientist, we got an engineer willing to surrender. Most of the German engineers, they want to surrender to the West. They don't want to surrender to the Russians. And so during the Cold War, the competitions, really a lot of time at the beginning, it's the competition genetically from the same German technology. This one side using the blueprint, try to reprint it, redo it, and what the other side is we got a brain power to talk about stuff. Von Braun was one of it. But during that period of time, Apollo mission, Cold War, the space competitions, one of the challenge is a lot of time you need to put human in a situation to make decisions on go or no go, fly or no fly, launch or no launch, under tremendous time pressure. So you need to have speed, accuracy trade-off, try to decide how fast is fast enough. And whenever you start doing that, people realize that we need to figure out a trade-off between human and machines. Okay, I think I mentioned this before. Is that how many of you ever heard the opera Carmen? Never. If I hum, see if you ever heard this. The tune is like ba bum 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 ba bum 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 ba bum 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 bum. Never heard that? You heard it before? Okay. If you heard it before, let me ask you a favor. Use your hand, tap the tune on using the desk. Can you do it? And then you know what's the tricky part? I can let you tap it using your feet or using a pen. You still can do it. Everybody can, once you're familiar with that tune. And what I'm trying to say here is that, generally speaking, hand tool is the extension of human hand, of our body. We can fully utilize this to interact with the new environment to express something very, very high level. Everybody agree with that, except once we start talking about this high tech, jet engine, this supersonic rocket, people realize that the space we're dealing with is not the regular human space. So it's almost like people talk about we're trying to control the rover. We're here, but the rover we're talking about is on Mars. So now there are time delay. There are all kinds of speed accuracy. We're getting into trouble. And some of you see that we're trying to use VR in some of our senior projects for the same reason. People are making judgment. Psychophysically, we are not trying to talk about things in our experience. So we're talking about things outside the scope, the scale of our own experience. So you're still tapping Carmen, but you're not tapping Carmen in the world you're familiar with. You're talking about something way outside your experience range. So in the 50 and 60, during the Cold War era, there's a bunch of scientists, psychophysicists, they're trying to help military to determine how to come up with a better way to fly a supersonic jet, how to control a lot of high-tech weapons with precision and accuracy. So J.J. Stevens actually worked for Wright-Patterson Air Force Base, just like the other people. During the Cold War, I already explained to you, last century, Industrial Revolution, the Germans, they are the pioneer in psychophysics development. But in the 50s and 60s, American scientists shine. And the other things is, during the Cold War era, we attract a lot of Top Gun scientists, try to figure out the development of physics and the development of psychophysics. And digital computer or the digital world control becomes critical for the success of all the NASA missions or the military might. Okay, and his most famous books, okay, is S.S. Stevens. S.S. Stevens is his wife, okay, and it's called Psychophysics: Introduction to its Perceptual, Neural, and Social Aspects. And for some of you said that you want to go for grad school, but you don't want to do operation research in long run, psychophysics or human factor is the directions you can consider, okay? My PhD is in human factor. It's more computational aspect of biomechanics. Okay, so now we're talking about those scale. We're start talking about the scale of the physics or stuff we measure. And I already told you guys, the physical world, whatever we measure, how high is too high, how hot is too hot, how fast is too fast, okay? Traditionally, we're talking about this in human space, okay? And go to Home Depot. Most of the time, it's very easy for you to figure out what is 2x8, 2x4, and lumber or material. Why? Because we're using inch, using foot. That's very ergonomics, right? What's foot? Your foot, size of your foot. And the thing is that when you start talking about in a VR world or in a submarine in a deep sea that you cannot see, you cannot feel, how are you going to measure those things? You translate that, right? You said that whenever I hear a beep and coming back in this much of human perception, equivalent to the real space, how big is out there. So everything is a transfer function of something. And so the 4 different scales, nominal scale, ordinal scale, interval scale, and ratio scale, they're still useful, okay? But except we're talking about those scales, not in the our intermediate human space. And so they run a lot of experiments, try to compare them, and the equations now, rather than using the log of Fitchner's, he uses power function. So psychophysics become a constant k times physics to the power of a, okay? And a term is the shape of the function. If a is greater than 1, it will grow up. A is less than 1, it will go flat, will even out. And a is equal to 1, phi equal to k, psi equal to k times phi. Then it's a linear function. So gradually, everything people can use in our sensory world, how fast, how cold, how whatever you're trying to judge, or translate to this kind of functions, okay? And I just want to show you a picture. You guys know what is this, right? Huh? Yeah, and there are autopilot ones, but a lot of them fly by human. And what's the number one problem when you fly something like this? Where's the pilot? Is it in the drone or somewhere else? Yeah, they're probably in the Nevada desert somewhere, flying this through satellite. And this thing's flying, probably close to, very, very high speed. And I'm pretty sure sooner or later, probably there already exists, just we don't know supersonic speed. How many of you seen Top Gun 2? Okay, so we're talking about the same things. The movie is for you to admire Tom Cruise, okay? For example, that entire mission for me is questionable. Do you guys think that drone cannot fly that deep to attack that valley and pour out? Can you use drone to execute that missions? I think it's doable. In worst case, you just lose sacrifice a few drones, right? But sacrifice those drones versus sacrifice the F-18 or those jet. What's the difference? Human life, right? You don't need to sacrifice human life. But what's the problem of flying the drone? The most simple one, motion sickness. Because you're sitting. How many of you ever been to a theme park, Six Flags or Hurricane, and watch the roller coaster film? You can very easily get motion sickness because the pictures, the optic flow, showing things that are moving forward, but you on a stable base on your chair, and then you're gonna feel the motion sickness because nothing is moving. Okay. And not to mention, in this case, they're flying in very, very high speed. Okay? So sensory integration is another hot topic in virtual reality because sometimes one sense is in one scale, the other sense is in different scale. Okay, so Stephen Power law here basically showing that, okay, he compared different stuff and say, loudness, vibration, sound, visual area, and taste. Okay, he measured everything. Okay, can you tell me, okay, what is the most striking high scale event here? If the parameter A is greater than 1, means what? We exaggerate it. Is equal to 1, 1 onto 1, the same scale. If it's less than 1, means we taper off, we get used to it. Just look at the number. Which one we exaggerate a lot if we get that kind of input? Which one? Which one you see is over 3? Yeah. If I zap you, even a 12 volt, tiny, not gonna kill you. How many of you ever experienced electric shock? Just a tiny bit can zap you and then you will feel the pain more than anything else, okay? So 3.5, that means something current through your finger, you will feel the zap. And you will say, oh my God, this is more than you can handle, okay? But on the other hand, okay, a lot of stuff that within human scale, you will see the value like vocal sound, pressure, white noise stimuli, static force on the skin. You see the ratio is close to 1, okay? Radiant heat on skin. Anything that you can sense in your daily experience tend to be reasonable in a human scale, okay? And there are certain things you can ignore. Those values will be less than 1. Sound pressure, if it's too high frequency, you couldn't hear it much, okay? And 5-degree target in the dark, okay? And point source, brief flash, you just ignore it, okay? And so what is important here is that if, okay, I'm trying to provide you something as a warning or let you feel scared, I should give you something with a power higher value. So, how to give a give a PowerPoint presentations, how to exaggerate those things. So you tend to say, oh, I need to move my VAR oh, this is dangerous, I need to do something about it. Or you can, on the other hand, try to taper off, let people ignore it. And one thing is not mentioned in here is about time. How many of you think time is physics? Or how many of you think time is psychophysics? Because survival analysis is about time, right? How long is too long? You think time is physics or psychophysics? Okay, I'll give you one example. You're spending 1 hour with a boring old professor, spending 1 hour with your loved one. Which one time flies? Huh? With the loved one. Which one will drag, man, when he's gonna finish? The professor, right? So first you can tell that, a boring lecture, a boring movie, it just feel like time is really slow. So time is a physical concept, and some physicists even say it's an illusion, but we know that time is relative, depends on the situation, right? And actually there was a UT Austin's professor did an experiment using random number. He let his subject students wearing a watch. The watch generate a bunch of random number, okay? So, but the random number generated in a very, very high speed. I cannot remember, how many arrive every, I think every 150 millisecond, it'll show one random number. And then he will say, ready, set, and go. Say, in regular situation, how many sets of random number can you remember? And then he put those kids on a bungee cord and push them, and when they just coming down in a very, very scary situations, okay? When they in that very, very scary situations, they remember more random number. Why? Because you ever heard this? During the accidents, a lot of victims said that they feel the time slowed down. Everything's in slow motion. Ever heard that example? Someone through a terrible car accident, a lot of times they can recall the entire accident because they feel it's in slow motion. Psychophysically, we can explain that because our eyes or our senses sense the environment at certain frequency. But when you're in a very challenging situation, your sampling rate increased. So your delta T become even smaller. And when your delta T becomes smaller, you have more opportunity to grab the random number, okay? So he proved that it's true. How fast or how slow also depends on what kind of situations you're in. And so later on, when we try to do the CVAR computation, we basically have a set of casualty data, whatever the survival rate data of some situations. But then we will give you a experimental, in the labs using virtual reality or something, and said that, okay, most people say that they can tolerate to this point, no more. So you will have a VAR cut, how much were you willing to risk, value at risk point. And so the entire homework at the end will be using the SAS, figure out the CVAR by doing three things. First, figure out the transfer function, and then using 1 minus that transfer function become reliability. And once you figure that out, you figure out where's your cut, VAR. You figure out your beta level, so CVAR equal to VAR plus I3 integration. I'll use SAS to show you how to integrate it, divided by beta. Then you will say, oh, what is the conditional value at risk for this event, for this kind of stuff? That's where we're going from now, okay? And And the other things is that for this expression, same things, right? If you log the phi, it becomes log k plus a times log psi become log k plus a times log phi, okay? So if I can figure out this value, this entire equation, can you use simple linear regression to find a parameter of a terms and your error rate? It's doable, right? And you just treat this as your y. This is the intercept. This is your x. So you can consider, okay, once you take log of some energy jump to some level, once you take the log, you linearize it, you can abuse linear regression to death. And then once you've done this and you try to figure out, okay, well, how can I manipulate this to say that, okay, I would like you to say yes a little early, or I would like you to say yes a little later. I would like you to say yes under certain x. I'll give you those x. The more x you have, the higher you jumpier you become. You are more likely to say, yes, 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 I'll do this. And the other thing is that when there are several exponential we can use with that exponential x, I'm basically trying to figure out which one I can add a little bit of something to give you the illusion that you're in more dangerous situation than the other situations, okay? People talk about this like warning sign, okay? Have you ever been to New York or any big major city when they have subway? There's a train coming in, please stand behind the yellow line. Usually the warning is in female voice or male voice. Female for warning, male for instruction, okay? And guess what kind of voice is the most annoying and scary? Kid's voice. And I heard this anecdote. They try to figure out, how to give verbal warning to a Navy pilot. They found that if they use their young kid's voice and say, "Daddy, you're locked by the enemy missiles," that would trigger their reactions a lot faster than the others. So baby voice is squeaky voice, right? What make you really annoyed in a long flight? Baby cry behind you, right? Right after takeoff, and never stop until the flight landed. And so high-pitched voice psychophysically give you more exaggerations. Okay, so one thing people did, here he is trying for different observer under different conditions, figure out who is more sensitive than the others, and how to use this is to, for like subject selections, if you want to have the subject very, very sensitive to a warning signal, you want to make sure that they're very psychophysically, they have a very high A value under certain conditions. Oh, let me ask you something different, okay? You will have fatigue if you have a lot of homework or you've been doing certain thing mundane for a long time, right? How can you maintain your level of alertness or pay attention to stuff? So you can be sensitive to certain physics. What can be used to help you improve that ability? Coffee? Do you drink coffee? Coke? Would that help? What else can help? Or, well, besides that, besides caffeine, cold air helps, okay? And the other things, do you think changing positions, posture helps? The most obvious example is lifeguard. Most of the lifeguard in the swimming pool, do they let them sit the same? They will swap them from station to station. Some, every 15 minutes, some every 20 minutes. Basically, change their perspective. Also, keep them away. Maintain the level of alertness. And so that's another psychophysics that people try to do to improve their threshold. And one more is called cross-modality. Cross-modality is like you are doing one thing, but I would like you to feel like you're doing something else. Have you ever tried the virtual reality Star Wars simulator in the mall? Sit in the mall, they have that actuator showing the movies. Have you ever done that? Okay. If you're watching a simulator movie or even playing a flying video game, you know that you can have the actuator, okay? And usually, say you're having a deep dive, high-speed deep dive, the actuator will tilt you forward or tilt you backward. Forward. And why is that? They're trying to use your semicircle in your ears, change your vestibular orientation, and use that to give you the synchronization with the optic flow. Optic flow is things flying fast. And then tilt forward to make you feel like you're actually accelerating. So psychophysics been used to change people's judgment. So suppose I have two psychophysics, Psych 1 and Psych 2, based on Physics 1 and Physics 2. They all have their own constant J and K, and there's power parameter A and B, okay? And of course, if I said that, hey, to tell this much equal to the acceleration of this much, so Psych 1 equivalent to Psych 2 in this way. And so you will say, when these two are equivalent, then the right side, the physics, must equivalent. And by doing this, you can take log on both ends and then basically figure out that, okay, if I want you to feel this much of speed, how much I have to tell you. If I tell you a little more, you will feel the speed increase this much. You guys follow me? So I have two psychophysical world, sensory. I need to find a scale function, and this is the way how to done it. It's called cross-modality comparison, okay? And people use the cross-modality comparison in modern days. It's basically in VR world, try to say that, okay, if I let you see or feel something, how to use one, translate to the others. Okay, so that finish our psychophysics. Okay, do you guys have any questions so far about the math or what we did, the introduction between psychophysics and the survival function? No? Okay, then let me give you I can use this one. Let me find one interesting. Live regression, look how I use this one. Okay, so this is the data we're going to use in one of the from the lecture, and the things where we're doing is this. We'll say that the regressions relate to a bunch of variables, And those variables will change the level of how we feel, how dangerous the situations. And if I plot those situations, okay, say at the end, I'll create two CDF function, okay? So if here's 1 to 0, and then here I can mathematically come up with a transfer function from 0 to 1. And if I tell you, okay, my VAR stop at 1,000, can you use this to figure out what is the value, conditional value at risk, based condition on that threshold we're going to have? Can you do that? So now we're going back, try to connect the dots of three things. We're going to still doing a bunch of CDF. And then once you have the CDF, we'll say that the CDF can move to the left or move to the right. Okay? If I give you more money, you can sustain a little longer. I give you more oxygen, you can last a little longer. And I give you something, can help you last a little longer. If I help you last a little longer, how much VAR or CVAR can you move or evaluate do? So let me put it this way. Suppose my VAR right now is 1,000, okay? If VAR is 1,000, okay? VAR move further to the right, your I3 will increase or decrease. Say, I move my VAR from 1,000 to 1,500. Okay? So my CDF, there's an I3 region right behind from ceiling down. Was that I3 increase or decrease if my VAR moved from 1,000 to 1,500? I3 will increase or decrease? Decrease. I3 decrease. Why? Here. Let me do it. I don't know if I can do it freehand, but let me try. Insert shape. Let me use this one. Okay, so consider this is my CDF function. Okay. No, let me do this first. After we start abusing SAS, okay, where's I3? I3 is here, right? Right? Agree? So here, when my VAR, psychophysically, I think I can wait a little longer. When I said I can wait a little longer, my I3 is increasing or decreasing? If I don't have patience, I cannot wait anymore. This from ceiling to the CDF, that's your I3. So when VAR move to the right, I3 increase or decrease? Huh? Decrease, okay? So that's one thing we can play with is, well, it's increase or decrease. You can guess, but I want you to see it. Because now we're just playing a simple game. Oh, can I wait a little longer? Right now you guys are thinking, well, he finished psychophysics. How long he gonna wait till he say class dismiss, right? So the thing is, one thing is you're trying to figure out is, what if I have two curves, okay? And blue one say that, oh, I can wait. The red one say I cannot wait for the same physics conditions. Obviously, the one weight, you'll have less I3 left. So you're taking more risk that way. But on the other hand, what if I said that, okay, because of COVID, economics, now the government said that, hey, I'm willing to put in more money. And why I'm going to put in more money? Because the more money I'm put in, I can, okay, so which one's better survival function? Is the orange one a better survival function, survive better, or blue one is better survival function? Blue, because it die slower. The orange die quick, right? And if you like this, it's even worse, die really, really quick. So now the question becomes, okay, in order to increase the I3 by 10% or 20%, how much I need to invest in order to extend the curve from this guy to this guy, given the same same VAR level. So now I have the same standard psychophysically. My standard is this line. Okay, and if I'm using this line, obviously my original I3 is too small. But how much money I'm willing to put in order to move this curve a little more to the right, and therefore you're going to have more I3 or better CVAR. So now we're not talking about psychophysics, we're not talking about physics, we're talking about the combination of the two to decide when you think people will willing to change their car, when people will willing to buy a new AC, tend to do something, have a fire extinguisher or something. So now is, if I invest this much, but psychophysically doesn't change much of what's going on, do you think that it's okay to pay the money or not to pay the money? And as a politician or policymaker, a lot of time, they're playing two things, right? They want people feel happy. It's a lot. What is more important to a politician? Their constituents really having a good life, or they feel like they're having a good life? They're feeling they're having a good life. That's why all the dictators, they control the news, because they don't want their people to know the truth, right? So the entire argument here is try to figure out if they have certain threshold versus there are certain physics, and how we're going to manipulate the two things to get it done the right way, okay? And there are a lot of PR firms in Washington, D.C. They are playing all the time with this kind of changing they're doing marketing for politicians, try to figure out how to change their voters' perceptions and how to actually done something, okay? Changing the curve from pink to blue is changing the physics. Changing the curve from this vertical line to this vertical line is changing the psychophysics. But in reality, the outcome is the combination of how you feel and what's really there. Okay? See you next time. Okay.